All right, good morning. So we've got, we just finished all of the 1999 physics mechanics stuff from the free response from yesterday. So I'm just going to keep going up, and we're doing 2000 today. So as we go, we'll be using the period of pendulums to estimate acceleration due to gravity. All right. And so we are attempting to measure the acceleration due to gravity at some location we don't know. We have a simple pendulum that swings past a photo gate located at the pendulum's lowest point, which records the time it takes for 10 rotations, 10 full oscillations. The period consists of a sphere of mass m at the end of a string of length L. There are 4 versions of this apparatus, each with a different length. All 4 are at the unknown location, and the data below are sent to you during the experiment. So we've got a bunch of different lengths, and the time it takes to complete 10 oscillations. Okay, first calculate the period and square the period, and use a reasonable number of significant figures. Then enter the results in the table above. So what would I have to do?
So just fill out the chart first.
Okay.
Wait, find the period, yeah. So we have t and length. Oh, then we can use the equation to find the period, right?
Well, what is this t?
Time taken for 10 complete oscillations.
Okay, and what is a period?
Oh, we divide by 10 for each.
Okay, so I can divide by 10 for each. Okay, and then square them for my period.
Yes.
Okay, I think I'm gonna quickly do this in the calculator.
Yeah.
So if I hit stat edit, I can type in a list of numbers. So here's 7.62, 8.89, 10.09, and 12.08. Okay, if I go up to list 2, I can make list 2 equal to list 1 times 0.1. So here's all of my first periods. And then if I want to square that, I can say list 3 is list 2 squared. Okay, so now I've got 0.581, 0.790. Seven, nine, 1.02 and 1.46. Okay, any questions on what we did?
Nope.
Okay, I do have a screenshot of the calculator here. Okay, then I need to plot the graph of the period versus the length of the pendulum. So I'm going to graph our points really quick. This is our length, and this is period squared. This will be 12.58, 12 and 0.58. See, this is 6, 7. Okay, each one of these is 0.1. So 12 and 0.58 would be about here-ish. Okay, 18.8. $21, 1.01. and 32 1.46. Okay, if I want to draw the best fitting line, what do I have to do?
Just draw a line that goes through all the points.
Okay, there's not any one line that goes through all the points. So if I can't draw a line that touches every point, then what should I try to make my line do?
Close. It doesn't need to touch, just it can go up and down a little bit. Like this.
Okay, so I'm going to draw a best fitting line so that half of our points are above it and half of our points are below it. So let me do that really quick. Okay, that was good. Actually, it'd be cool if I could pass through 0 too. Okay. So something like that.
Yep.
Okay. Then I want to determine the fit, or use our fit to determine the experimental value of gravity. So how can I use our period of the pendulum to figure out what the value of gravity would be?
You just use the equation, right?
Okay, what's our equation for the period of a pendulum?
T equals 2 pi square root L over G.
Okay, right now on our graph from the other page, we have t squared and L. So how can I solve for g?
So if we write in terms of G in the equation, then it's gonna be T divided by 2 pi, and then times, then square it, and then divide by L again, L over G. So T times, T div, wait. Oh, never mind. 4 pi squared times L divided by T squared.
Okay, so what I'm going to do is, because I've got this equation for the slope already, so I'm actually going to solve this for slope. What's my slope of our best fitting line right now?
Slope of
From our graph on the last page, what would the slope be equal to?
changing L over changing T squared.
Language difference, I think. So,
Oh yeah, change T squared divided by L. And then if we times 4 pi squared, that's gonna be our G.
close. 4 pi squared over g. Okay, so that means this t squared over L is really m. And now I can solve for g. Okay, so that means gm equals 4 pi squared, or g equals 4 pi squared over r m.
What is M?
M is the slope of our best fitting line that we got from the last problem. So I'm going to go back and we'll see if we can get an estimate for our slope.
It's reciprocal of the slope.
Okay, so I've got this point at 0, 0, roughly, and this point at 10, 11, 12, 13, and 0.6. Okay, so this is
0.0 and 13.0.6. So that is 21.67. And then we have to divide by, no, we have to reciprocal. Because M is in bottom.
okay. I think I'm just gonna.
I mean, yeah, 4 pi squared divided by 21.67. That's gonna be our G.
Okay, so let me wake this back up. So we had 13 divided by 0.6. I'm going to do 4 pi squared. And divide by that answer.
Yeah.
Okay, so I've got 1.822. Ah. What are my units?
Gravity is meter per second squared.
Okay. So before I move on, why did we use the slope here?
Why do we use the slope?
Mm-hmm.
The slope, what do you mean?
I had all 4 of these points.
Oh, because slope is the best fitting line.
Slope is the best fitting line. So this slope is going to consider all of the points.
Yeah, consider all the points.
Um,
It's the best fitting slope.
right, so that's actually better than using an average even.
Yeah.
Because we're considering every point of data that we have. If we can get a trend line that we could use to make predictions for data we don't have, that's even better than just using the points that we have, right?
Yeah.
So anytime that you can use a slope to get a value in your equations, you're going to want to do that with your best fitting line. Okay.
Wait, but this one we need ruler. Can we use ruler in the test?
I don't think they give you a ruler in the test, but we can do estimates. So you could use a straight edge for the other sheet of paper if you want.
Oh.
So just fold up a corner and draw that. What am I doing? If the measurement allows a determination of G that is accurate to within 4%, is your experimental value in agreement with 9.8 and justify your answer? So we got G is 1.82.
It's out of 4%.
Okay, I need to justify it though. So how would I justify it?
Because our G, we used, so first we used the period for 10 complete oscillations and divided by 10, which is the average. So our G is not accurate, that's why.
Okay, I'm not really asking why we aren't accurate. I just want to prove mathematically that it's not accurate. So I need a line here somewhere proving that this is not within 4% of 9.8.
Oh, so 0.8 times 96 is 0.96 is the
Okay, I think I see what you're doing. So I could say something like this. The acceptable range is 9.8 plus or minus 9.8.
Yeah, 0.496.
0.04.
0.04.
Okay. Which we'll solve really quick. Okay. Times. Okay, so that's 10.192 and 9.408. Okay, so we can say therefore our okay.
Our experimental value is out of the range.
Okay. So what does that tell us?
Found wrong oscillation.
I don't think so. I think our acceleration's okay.
Or we consider all the friction or external forces.
We don't know where we were. So, without any other information, I would start thinking maybe we're not on Earth.
Yes, oh, yeah, that's true.
So we'll see if they give us any other information. Okay.
Yeah, we just.
Okay, so we are actually on Earth, but the experiment was done in an elevator with a constant acceleration a. Okay, so if this is exact, determine the magnitude and direction of the elevator's acceleration. Okay, so we were in an elevator. That means the force of gravity that we found would be pulling down here. If the elevator was accelerating upwards, would our gravitational force be more or less?
Gravitational less.
If the elevator is going up, gravity is going to be less?
Oh, more because that's to pulling down.
Right. Okay.
That's why we're feeling more weight. No, I mean feeling more weight, right? When elevator goes up.
Right. So the elevator must be moving downwards. Must be, say, accelerating. To detract from the acceleration due to gravity. Okay. And then I need the magnitude as well. So we just got direction. How can I find magnitude?
Weight is equal to
Okay, you're right. Keep going.
mg.
So weight is equal to
Ma.
ma.
You have more?
We should have more. Okay, I'm actually going to add to this side, I think. So my difference in our weight and what we're looking for, so some force should be equal to the net force. This this weight here, yep, is mgu, which is what we found experimentally. Should be m times the net acceleration. Therefore, we've got mass, 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 and everything. So I could say g minus gu is equal to a. Okay, g we said is 9.8. And then our gu was 1.8 something. 1.82. Okay, what's my units?
Meter per second square.
Okay. I'm gonna write on this side, I think. A equals meters per second squared. Okay. At a rate of 7.98 meters per second squared. And okay, that's it. Any questions on anything we did today?
No.
All right. I'll go ahead and post this to the chat then. Thank you so much for coming, and I'll see you tomorrow.